Hi, everyone. So quick show of hands before we get into this. How many of you are using some framework for managing your data pipelines? Okay. And how many are using shell scripts and cron? Okay. All right. So this should be relevant to a lot of folks. I'm Mark Weiss. I'm a senior engineer at Beeswax, and we're an online advertising company here in New York. And my background, just really quickly, I've been sort of in ETL and data processing kind of space pretty heavily for like the last 10 or 12 years. So I've seen a couple different permutations of this problem space. So we're going to talk about a little bit about Beeswax, what our business does, how much data it generates. As Rick mentioned, it's very high volumes of data, what our pipelines are doing right now. We'll drill into an example, and the idea is to show you that using two very different frameworks and trying to leverage what they promise and what we hope they'll give us, what it looks like to actually try to build that example. And those are going to be Airflow and AWS Data Pipeline. And we'll kind of hit the reality checks of what they do and don't do for us. And then ask and answer the question of like, okay, well, if they're not giving us all these things, is it really worth committing to a framework? What do we get from it? And kind of wrap up by saying when you put all this together and do the lifting you need to do around the framework, you're living the dream. So first, let's talk about Beeswax just a bit, what we do, and the data flows. So we're a programmatic advertising company, as Rick just mentioned. So what that means is you go to a website, you open an app, there's an ad slot there. The publisher publishes a description of the ad. It gets sent to these exchanges who roll up millions of these a second and forward them on to buyers of ads like us. So we're what's called a real-time bidder. That's our platform. So our customers are advertisers. We're buying ads for them. From the point of view of this talk, what's interesting is that this generates a lot of data. So we're just breathing in this fire hose of millions of requests a second on the front of our system. And we have to respond to them all really quickly. Just as a side note, that's one of the cool problems we have to solve is a very high scale decisioning, very fast. So this generates a lot of data. So the bid requests are all these ads coming in. When we bid, we log that. When we win, that's called an impression, we log that. Later on, a user clicks, that's a different event. Maybe 2 weeks, 3 weeks later, they go visit a website, that's a different event. So we have all these asynchronous data streams that are coming into our system. So our main ETL right now is written in Data Pipeline and lands data in Redshift. And of course, probably like many folks here, that's an architecture that we're evolving past, I would say, as a side note. But right now that's what happens. And so one of the challenges there is dealing with all the scale, and another challenge is joining all these asynchronous streams. And also we have to do some tricky things like figure out that 3 weeks ago you saw an ad and now you're visiting a landing page, and those two things are connected. Right. So that's kind of the current ETL. And then the, okay, yeah. So this is also showing, this is a little out of order, sorry about that. This is showing the scale I was mentioning. So we've got, billions of the auctions coming in and tens of billions of requests. We log all the requests. And we've got hundreds of millions of impressions. And this data isn't just for internal use. This is core to our product and our differentiation. So we have to handle all this gracefully, correctly, with low latency. The data has to be fresh. And that's because reporting is key in this domain for customers. They need to understand how their campaigns are doing. But also, one of the differentiations of our business is we deliver all this data back to our customers as part of a flat platform fee. And so the data itself is a key part of the product. The other set of pipelines are newer. Of course, that's the Airflow piece there. As we're disgruntled with data pipeline and we're looking for something better. So there we are basically just building a pretty typical use case, I hope, that some folks here can relate to, extracting data from Redshift, landing it in S3, building a data lake over that's holding the data for a lot longer than we hold it in Redshift. So that's using Hive to do that. So basically, right, so one more slide here just showing the growth of the data and why we've been focusing on the data pipelines. Why we were looking for a better solution than data pipeline and looking for a whole next generation way to handle this. One reason I mentioned the data is core to our business and it's strategic. And we know we're going to need to keep investing in that. And it's a differentiation, so we have to be nimble there and be able to scale. Second reason is just the business has been scaling. So this is this year, and this is basically the top line metric of impressions. So this is ads. This is what we do. We buy ads. So we're basically at 3x start of the third quarter from the beginning of the year. And this is a seasonal business, so we know it's going to get even higher in Q4 and so on. So we have a good problem to have. We have to scale our pipelines. So let's look at this example. Let's revisit the data lake example. And this is basically what I had to do was say, okay, so what technology should we use to build this data lake? And again, just really quickly, we need to extract the data from Redshift, land it in S3. That's one step in this pipeline, and then another step is to basically put a Hive table over that. So data pipeline versus Airflow. So I looked at a bunch of different choices, and it kind of boiled down to these two. Data pipeline we'd already been running for 2+ years. We know how to run it, but the way that we run it is we built a lot of our own tooling around it. So the APIs are pretty painful. Even something simple like figuring out if a pipeline's already running requires some gymnastics and so on with the APIs. And the UI is terrible. The retry story is okay, but not great. So it works, we know how to use it, but we weren't really happy with it, and we felt like we were spending a lot of time on it. It wasn't maybe a way to scale going forward. So we landed on Airflow, as Rick mentioned, like a lot of people are doing. It's clearly gotten the traction at this point. It's the shiny object right now. It made it to Apache Incubator, and it's actually now the first hosted pipeline service on Google Cloud and so on. So it was kind of the de facto other choice, so we said, let's see what we can do with this. So this decision felt a little bit like this, the first joke of the presentation, right? Data pipeline is like a typewriter. Like, we know we can put paper in and hunt and peck and type something, but that's about what we can get out of it. We're hoping that with a higher learning curve and the shiny new object, we can get a much powerful general purpose tool for going forward. Right, so let's drill down now and build, this is executable code, build the pipeline with these two choices and sort of see where we land. Leaving aside kind of all the other aspects of pipeline that are specific to just how pipelines work and looking at our specific requirements for this pipeline, we know we need to do these two things. As I mentioned, we need to unload the data from Redshift to S3, and we need to put a Hive table over it. So one of the promises of these pipelines that you sort of hope for, especially with Airflow, which has dozens of canned operators that it provides, and operators are the code that actually perform the steps in the pipeline. You're looking at it hoping to get some code reuse there and not have to write this code yourself. And so the first question I wanted to answer is, was that going to end up being true or not? So let's look at Airflow first. And the first thing that I saw was, oh look, it's open source, it's in GitHub, and there's exactly the operator we need, Redshift to S3. So that seemed like a really promising start, but then when we drill into the code, right away we see problems, and this is going to be kind of the theme of this part of the talk. For example, the way it was handling credentials wasn't the way we wanted to. There was no support for SSM, which is the way we do that everywhere and want to do that. So even right there in the guts of the code, it's not doing things the way we want to, and we would be looking at forking it, managing our own version, something like that. Another example of this was at that time, the version of Airflow we were using then didn't even support passing an argument to control whether or not when you extract the data to CSV, there would be headers or not. This is like an extremely basic feature that you're always going to want to control, and at that time it wasn't supported. So that's just a small example of the brittleness. So the strength of this model is you have these reusable operators, you compose on top of them at this high declarative level, and you can build out whole applications. But the weakness is if the operator doesn't allow you to parameterize it the way you want, that's the only way you can change its behavior, is passing arguments to it when it runs. So if that's not exposed to you, you're stuck. So similar and even worse problems with data pipeline. And this is kind of cheating because we'd already solved all these problems at this time by basically writing all our own custom way of putting Python shell activities out and running them in data pipeline. But let's pretend. So if you look at what they offer out of the box, there's this UI, this sort of visual builder, which is basically a non-starter because you're pasting your code in there. So that's not going to work in terms of deploying version code. You can point it at scripts on S3, and then you're building your own tooling to extract from your repo and land the thing in S3. So again, you're not getting this off-the-shelf, out-of-the-box kind of experience. Furthermore, they're just giving you kind of these generic operators that don't implement anything. It's a way to run SQL. So you still have to write the SQL. So in that way, you're getting even less of an implementation than with Airflow. Right, so basically, we took a look at these frameworks. We tried to do something with them. And the first thing we realized is the operators they're giving us aren't giving us what we need. And as I kept digging in, I realized this was not just specific to these implementations, but this was basically an attribute of how data pipelines work, this model of building applications, and that this is going to be true no matter what framework you pick. So, let me back that up just a bit with some more examples. So just summarizing again sort of what we found initially. We couldn't use these operators the way we wanted because there were things we wanted them to do that they either couldn't do or they weren't doing them the way we wanted. These are the specifics, so authentication, headers, deployment, versioning. But then I looked at the rest of the way we build all our applications at Beeswax, and we're a business that's several years old. We've been using Python in production for years. Airflow is all Python. So the hope was we'd have this seamless integration path. But the truth is you operate, a big part of your applications running in any cloud environment or really anywhere is all the rest of what makes them production. So how you do monitoring, how you do logging, how you handle errors, all these things. And you want your pipelines to run the same way ideally because it's a lot less valuable to have this general purpose system to declaratively put computation out in the cloud if you have to do everything differently just for this thing. It's much nicer if you can leverage and operate it the way you run the rest of your stuff, right? So in this example, we always like to emit certain metrics to Influx. We rely heavily on it for dashboards, for monitoring, for on-call support, all that kind of stuff. Also, we have metrics-driven alerts, so we need to be able to do that. And so there is some support for this kind of thing in Airflow with hooks. Hooks let you wrap events and you can write custom hooks, but you're limited to responding to the events that you can respond to. You can't just put code exactly where you want it in the operator implementation. And also then you're writing your own hooks. You're now managing and maintaining your own code once again already, even if you're trying to reuse their code. So basically you're not getting all that benefit that you want. And then, the second example of sort of alerting, this PagerDuty example on the right, let's say you want to emit a message right from an exception block because that's where you have all the context and you can write that rich message of exactly what failed and emit the exception itself, the stack trace, all that stuff. You don't have that kind of hook in any of these implementations. You need to be writing your own code to have that kind of control. Right. So, and the last thing is, we want to import anti-gravity and fly, right? Of course. Joking aside, we had, as I said, we had all this Python code to do, and we'd solved lots of problems already, right? So we have our S3 clients and PagerDuty clients, on and on and on. And we want to reuse all that, and we want to just import that in, import, et cetera, import beeswax dot, and use it. But there's no way to do that at all with AWS data pipeline, and with Airflow, you have a plugin API. You can wrap things and implement their entry point, their plugin entry point, and then again, you're maintaining shims, you're maintaining this separate way of integrating your code. You don't have a path to just build these applications just like all the rest. So that's the first reality check, a rather probably long way around making the case, which is that the more you look at this operator code, the more reasons you're gonna find that it's not gonna work for you. So I would assert that if you're looking at this problem space and you're looking at building out a data pipeline platform for your company, you should expect to implement your own operators. and in fact just embrace that, right? And again, this is why, because this is code that is, the only way you can parameterize its behavior is by passing arguments to it when it runs. So, unless everything is exposed to you exactly the way you need it, you're not going to have the control you need. So we just decided to take this problem head on through a simple inheritance pattern, right? So we just basically put our base operator over the Airflow base operator and wrapped up all the plumbing that needs to make operators work with Airflow, package up the arguments that in the way it wants, pass them in, and all that in our base, so our users don't have to think about that. And then we know everything's going to work with Airflow. Airflow is going to be able to trigger our operators. And then, the nice thing about this also is this gives us a really nice two-level pattern for laying in the general services that I was mentioning. So for example, if we want the same metrics to be written by every operator with the same dimensions tagged on them and so on, same semantics, we can put that in the base class. And then now for free, all the operators we write are going to emit the same metrics. So for example, just simple things like duration of the task and success or failure count, those kinds of things. And then likewise, if there's services that we want to lay in to a specific operator that require its context, we can put them at that level. So that's just an example of how to address this problem, an example of how we addressed it. But the idea is you should expect to address it in a way that works for your needs and works with what you already have. Right. So second example of where you're going to basically need to do lifting yourself is, is deployment, packaging, deployment, all that stuff. Right. So here's our example again, just as a refresher. So the basic idea is these pipelines are a lot more than just the DAG, which is the description of the steps that run start to end, and the little Wikipedia DAG picture there. It's all like all the rest of your software. It's everything that you need to do to put it out in production and run it somewhere for real, right? So, at a very, very high level, the pipeline model is that you've got this DAG, which describes the steps you need to execute. You've got the configuration, which passes the arguments to it at the time it's invoked and run, and all the rest of the code dependencies that it's going to run. All that needs to be somewhere, and it needs to run somewhere. So this is a high level, extremely high level, simplified picture of what this looks like on Airflow, or an approach to it. So you've got to figure out how to package, as I mentioned, put that in a container, for example. Let's say you're going to run things that way, somewhere, and put that on a host somewhere. That's the code that's going to run. With Airflow, you're also responsible for putting the whole Airflow service somewhere else. So that's on some other host, maybe the same host. The simplest model is to put everything all in one place. And Airflow, in fact, has three processes that you're thinking about running. There's the scheduler, there's a web app, and there are workers. So the simplest model is all of those are on one host, even with your code. You could do that. That's how we started. But even then, you also need to have separate MySQL that Airflow uses for the scheduling state, Redis for the task queue, which are actually it puts these tasks up that the workers then consume, and that's how the pipeline actually runs. So you need all this infrastructure configuration, and you need to do all this stuff yourself, and then you need to keep it up and running, right? So AWS, despite the fact that it's a managed service by name, as soon as you get out of the trivial support it has for doing things within what it offers fully managed, you're doing a lot of the same stuff yourself. You're figuring out how to package your code and put it out somewhere on a container. So we do that in ECS right now. You're running this separate process called the task runner, which is an AWS application that you configure to point to where your containers are. So what you're getting out of the managed service is really largely the same things what you get from Airflow, which is a scheduler and a UI, and it's a painful UI. So sort of second reality check, which is this is not serverless yet. Maybe some other speakers will address that or have. And it's not no ops. Like, you need to do all the same things you need to do with the rest of your applications, and you're going to want to do them probably the same way, because there's no value in doing them differently, and there's a lot of value and having this thing run the way the rest of your stuff runs. So, okay, I just spent the first chunk of this talk talking about all the things you're not going to get from the framework, providing some specific examples. So is it worth using one of these? And I would argue it is. These are sort of very high-level, obvious reasons why. Basically, this whole domain, it's generic, right? That's in fact the entire value of it, and the entire point of it is this general purpose way to put processes out somewhere, out in production, and have them run, and to use this high-level declarative means to do so. So you want this general thing, but a lot of the aspects of a pipeline system are general and not differentiating for your business. So scheduling is really kind of the most obvious example of this problem that seems beguilingly easy that you want to solve yourself, but you should not, because it has edge cases and it's also a mature problem that has been solved, so don't solve it. And scheduling is the same for everyone. Daily is daily. Also this idea of, oh, it's just a DAG library, I can do that, I learned that in school, et cetera. But the whole full solution is a lot more than a fun little DAG library, right? So another argument I would say for picking a framework is just to pick one, because what we found over being a fast-growing startup over the last several years is this is a really obvious pattern of you've got data here, you need to do some computation, you need to land it there. Like basically this whole, anything that's not a streaming use case or an online transactional use case or sort of a web app, which is a form of transactional use case, is this use case of like a process needs to start up and do some stuff and then stop. And we need to know, did it succeed? And then probably it depends on other processes and all that. That's a whole separate problem. But the idea is you're going to rewrite this over and over again. So that's probably not, that's not high value because this mechanism itself is generic in general. So just pick something, commit your engineering effort to that platform getting better and better and being more useful across your organization, across your services. And you can bake in, as I was mentioning earlier, all these aspects, you can bake them in and have it do everything the way you want. It can do logging the way you want, monitoring, alerting, security, all that. So it's just worth picking something. And you do get a fair amount. And again, it's all sort of general stuff that there's not a lot of value in building yourself. You get scheduling. You get an API for defining DAGs, and we can argue about whether the Airflow way of doing it in this sort of almost pure Python that doesn't exactly work like that, whether that's the best approach or a visual approach or whatever. But in the end, it doesn't matter that much because you have an API to hit for doing that. You don't have to design that yourself, build that yourself, manage that code yourself. And again, even though you don't get the whole runtime environment, you get a target to hit, right? So you don't have to figure out the architecture. There's an architecture that's basically given to you for any of these frameworks you pick. What config you need, what environment variables, what's supported in terms of where it can run, what are the supporting services it needs. So you have you got the boxes and arrows already, and you know what you need to build. And so you're starting there, you're starting at a higher level, and you know if you hit that target, it should work. Right? You also get everything about pipeline semantics to one degree or another. So you have policy for what happens when one task fails. Should the next one run or should it stop? Should it wait or can it start right away? So you actually have, especially in Airflow, which has rich policy around this stuff, you have a concurrency policy at the same time as sort of a task failure policy, just in how you can define the behavior of the DAG. You get retries, and both pipeline and data pipeline and Airflow handle retries pretty well. Airflow has very robust support for backfill. It's been one of the features I've been most pleased with. So it does a really nice job of keeping track of all the jobs that are supposed to run ever. And if they fail, it keeps trying to rerun them. It's also really nice in terms of you can stop it in the middle and it will pick up from where it left off and all this sort of thing. And these are all things that are generic to how you want pipelines to work. They're hard to get right, and it's done for you. And the last thing is you get this UI. I should have shown you the data pipeline UI, but didn't want everyone to run out of the room, so I'm showing you the Airflow UI. But the idea is you get this nice UI. It lets you look at status. It lets you manage these things manually. You can go manually retry things. You can jump to the logs, all this sort of stuff. Airflow also has reports on how long things have been running, and all this sort of thing built right in. So, again, this is a whole web app that you don't want to build yourself because it's just general to managing pipelines. You just want someone to do it for you, right? So, not running quite full time, we're almost to the end here, but basically wrapping up the idea. So what do you get when you put all this together? You take the pieces you get from the framework, you build out the other pieces you need, which are basically going to be the actual code that's going to execute the way you want, doing all the things the way you want, integrating the rest of your code the way you want, and some kind of set of solutions for putting that out into production and running, right? And I was at a meetup recently, and I think one trend that's happening is people are moving to a higher level declarative abstraction around Airflow, or another tool, another framework that encapsulates all of this, right? So enable data scientists or data engineers, customers of this platform, the ability to just declaratively say, I want this pipeline to run, I want it to pull data from here, I want it to land data here, and that's it. And then boom, it runs. So once you get to that point, and that's the path we're going down too, and that's the path I've been on much of this year, on and off, sort of figuring out how to wrap Airflow and get what we can out of it. But if you get all the way there, it's really powerful because now you've sort of taken this DevOps idea, you could say, of declaratively saying what the end state is you want in production of something. And you've moved up the stack to basically being able to declare a full application now, not just infrastructure, right? It's infrastructure plus computation. And even more so, this idea of having the operators be generic and know how to, for example, I know how to talk to Redshift and run a query, and being parameterized by config, you can compose new applications then by composing the operators in different ways and giving them different config. And again, you're not writing any new code now. So you've got this very powerful framework. I would even argue that it's more powerful than that because so far this model, or this way of thinking about building applications, is largely focused on the data domain, but there's no reason to limit it to that. Operators can do anything. And as I mentioned earlier, you're going to be seeing this pattern. You have this pattern all over the place of writing these basically batch job code, glue code. And it's worth thinking about, if I have a platform that does all this for me and I can operate at this higher level, I can move much more quickly and not keep resolving this problem. And you can apply it sort of any place you need to do this kind of computation. So if you get all the way there, you're living the dream. It's unicorns and rainbows, right? So that's the talk.
Do you think the issues that you ran into with the community operators are a sign that that approach is fundamentally the wrong one, or is it just that the project's immature and they haven't been built out yet? And if the latter, have you tried contributing back to the project, and what was that like for Airflow?
Right, so it's a good question. I mean, you can make things work, right? So you could take one of two paths with this sort of thing. You can find a way through making the black box thing work for you and make the set of compromises you need to make. The path I felt was much more productive for us was the latter path I described of just taking control of that and finding sort of the minimal shim to connect to Airflow and go in that direction and basically take all the general stuff from the framework that I don't want to build, and where we want control, keep control, right? Sort of like standard way to think about buy versus build. In terms of your question of contributing back, I did open an issue about the headers thing, and then it was fixed in a later version. So to that degree, yes.
You mentioned earlier about using a declarative interface on top of Airflow. Do you have any examples of any tooling out there that is trying to do that so you don't have to write all the code yourself?
Right. I don't know of any projects that are in wide use that are doing that yet. I was at a meetup recently, and actually it was meetup itself. We're talking about how they're handling this. And it was basically like, here's a YAML that describes my job. And it was over both the DAG and the database dependencies and sort of where it was going to run. And I do think that's a sort of obvious direction that this is going to go in and should go in. I also know of friends at other larger internet companies that are working on the same idea. I mean, the way I say this to people is that this is sort of like the assembly language of data pipelines still, right? Like, I mean, also there's some folks, I don't know the name off the top of my head, but they're writing languages that are sort of data pipeline languages. That's another way to put a higher level abstraction on the same set of problems, is bake in right into a language, sort of, for example, accessing resources and so on. But I mean, this idea of having to carefully assemble all the steps, step by step by step, it does not feel like the endpoint to me at all.
What made you go with data pipeline in the first place? And I don't know, do you regret that decision now that you have to cut over to Airflow?
So, we're now getting into my personal history at Beeswax. So that decision predated me. I regretted it, that it had ever been made, very quickly. But that said, you can make, like, we're engineers, you can make things work. So data pipeline really, by the time I got there, we had this built out our own set of primitives to operate with it in a reasonable way. So we had wrappers for putting our code in a container and putting that out somewhere. We knew how to run Task Runner and almost never had to think about it. And we had wrappers around basically the making the pipeline piece so that the scheduler knew about it, and having it, all the config and dependencies all be wrapped up in the, we had solved that. It's just that the gap, my point in the talk was more the gap between what it promises and what it delivers is very similar with these two things, even though one claims to be a managed service, the other's a new open source project, and you kind of end up in a lot of the same place with both.
Have you looked into AWS Glue at all, and would you consider that as an alternative to Airflow or not?
So interesting. I actually did look at it around this time and tried to build something with it. It felt immature in a couple ways. The UI was painful and sort of slow and a little bit unreliable maybe, but okay. But also, we ran into some race conditions relying on it as well, in terms of sort of not really read your own rights, but like read your own DDL rights. And so we just felt like it was a little, and again, it was very high level UI. It was like a extremely simplistic web informatica, maybe kind of. It seemed like my take on it was targeting more of an enterprise use case, where we wanted, again, it's like the same thing of buy versus build. We wanted a lot more control over the execution part of this problem.
Any more questions? Here we go.
Have you guys considered other task managers like Luigi or Uzi or whatever?
Right. So I did look at Luigi just in terms of the features, and I like that Airflow had a more kind of complete feature set. This was at the point where I thought I was going to get everything out of that. But I still think, I haven't done a lot with Luigi to really say, but that was kind of my take on it then.
Any final questions? We got one over here.
Yeah, thanks for the talk.
Sure.
So, just a design question. You decided to, base off of the base operator. Mm-hmm. Why not just go with the, extend the Redshift to S3 operator? You mentioned, the security thing was a concern, but did you just dismiss everything else, or do you guys just have other operators that you want to work on?
Right, so that's a great question. So this is a question kind of between, was I solving just that specific problem in the moment or going for a more general solution? So what I decided was that we already knew we needed, for example, just for this pipeline, a Hive operator. We're looking at wanting operators to spin up EMR clusters and Spark and other things down the road. So what I was looking for was a general solution to the problem that would let us build out other operators and solve this problem of being able to customize all of them in certain ways with one pattern and let each of them customize themselves specifically if they needed to. So that was kind of why I went with the inherit from the base operator and let us build out our operators. It doesn't preclude us from using any canned operators that perfectly fit our needs. It's just the DAG just constructs one of those and you're good. But to kind of get us out of this brittleness into a place where we felt we had the flexibility to move forward confidently, knowing we kind of had this open flexibility, that's why I went with that approach.